All right, let's dive right into one of the most mind-bending questions you can possibly ask. It sounds like something straight out of a movie, but it's a question that some of the sharpest minds in physics and philosophy are taking very, very seriously.
So let's just put it out there. What if all this, everything you see, everything you feel, all your memories, even your consciousness, what if it's all just lines of code in a ridiculously advanced computer program? And look, this has moved way beyond a cool sci-fi idea. This is a legitimate hypothesis that's being debated right now, one that pushes science and philosophy to their absolute limits and forces us to ask, what is real anyway? Now, to really get our heads around this, you have to know that the idea itself isn't new at all. It's actually one of the oldest questions humanity has ever asked. It's just been given a modern, high-tech makeover for the digital age. I mean, we can go all the way back to the 17th century, to guys like René Descartes. He famously worried that some kind of evil demon could be feeding him a complete illusion of a world that didn't actually exist. The core question is exactly the same. How can we be 100% sure that what our senses are telling us is the real deal? The classic brain in a vat thought experiment is just the modern version of Descartes' demon. And it hits on a really crucial idea for the simulation hypothesis. What if consciousness doesn't need a body? If all the signals that create your reality could be perfectly faked by a computer and fed directly to your brain, how would you ever know the difference? The scary answer is, you probably couldn't. Okay, so that's the philosophical setup. Now let's jump forward to our time, to the one argument that really blew this whole debate wide open, all thanks to philosopher Nick Bostrom. And yeah, he really dropped a bombshell with that line from his 2003 paper. It's an absolutely wild claim to make, for sure, but it's not just a guess. It's the conclusion of a really tight and surprisingly simple logical argument.
Bostrom lays out what's called a trilemma. He says one of these three things has to be true. Let's walk through it. Option 1 is doom. Civilizations like us almost always wipe themselves out before they get advanced enough to run ancestor simulations. Okay, plausible. Option 2 is disinterest. Super advanced civilizations just aren't interested in running simulations of the past. Maybe it's boring to them, who knows? But here's the kicker. If options 1 and 2 are false, that only leaves option 3. If civilizations do get super advanced, and they are interested, they'll inevitably create billions upon billions of simulated realities. In that case, the number of simulated minds would vastly outnumber the real ones, making it a matter of simple statistics that we are almost certainly in one of the simulations.
So the philosophical case is pretty compelling, right? But what about actual physical proof? This is where we shift gears from philosophy to physics. And trust me, this is where things get really strange. It turns out our universe has some quirks that look an awful lot like a computer program. Just take a look at this comparison. It's kinda uncanny. Our universe seems to have a smallest possible unit of distance, the Planck length. You can't get any smaller. Well, what does that sound like? A pixel on a screen, right? And what about the speed of light? It's the absolute unbreakable speed limit of the cosmos. That feels a lot like a processor's speed limit, a hard cap on how fast it can run calculations. And finally, the fundamental laws of nature are all described by elegant, precise mathematics, almost like they're lines of code in a master algorithm. This idea is captured perfectly by physicist Max Tegmark. His big hypothesis is that our universe isn't just described by math, it literally is a giant mathematical structure. And if reality is, at its core, just math, then it's not such a huge leap to think of it as a computation running on some kind of cosmic computer. Okay, so if the universe has these features that feel suspiciously like a simulation, the billion-dollar question is, can we test it? Can we poke at the walls of reality and see if we can find a seam? Well, believe it or not, scientists are actually trying to figure out how to do just that. Think about it like a video game. If you push it to its limits, try to break it, sometimes you can find a glitch, a weird visual bug or a character walking through a wall. So the ultimate goal for these scientists is to try and find a glitch in the matrix. And these aren't just vague ideas, they're actual proposals for experiments. For instance, some physicists are studying the most energetic particles in the universe, cosmic rays. There are theoretical limits on how powerful they can be. If we found one that shattered that limit, it would be a huge red flag.
Another wild idea involves quantum experiments to test if reality only renders its details when we're actually looking at it, just like a video game, only renders what's on your screen.
But here's the crucial bottom line. So far, nothing. Zilch. For all these brilliant proposals and searches, we have found zero definitive evidence. No glitches in the code, no error messages from the developers. If we are in a simulation, it is an extremely well-written one.
So now let's flip the coin and look at the other side of the debate, because there are some very powerful arguments that we are not in a simulation, and that it might even be a logical impossibility. And the case against simulation theory is pretty robust. First, like we said, there is zero direct evidence. Then there's the big problem that the whole idea might be unfalsifiable. If the simulation is perfect, how could you ever prove it from the inside? Plus, all the weirdness of quantum mechanics can be explained by, well, quantum mechanics. You don't need a simulation to make it work. But maybe the biggest argument against it comes from pure mathematics. This gets into what's called the Gödelian trap. Essentially, the mathematician Kurt Gödel proved that in any complex system, there are true statements that can't be proven from within that system. Some physicists think this applies to our universe. They argue that reality might just contain a level of complexity that is fundamentally uncomputable. In other words, no computer, no matter how powerful, could ever have enough processing power to actually simulate it completely. So where does that leave us? On one side, we have a really compelling philosophical argument for simulation. On the other, we have some serious scientific and mathematical counterarguments. We are standing right at the very edge of what we can know. Because at the end of the day, that's what this is, a hypothesis. It's a mind-expanding, incredibly fascinating idea, but it's not a proven theory. It sits firmly in the realm of speculation, not established scientific fact. But maybe the real value of this question isn't about finding the answer. Just thinking about it forces us to confront the biggest questions of all. What is consciousness? What is information? What is the fundamental nature of reality itself? It's a question that expands our minds, whether our universe turns out to be the real one or not. So I'll leave you with that final, lingering thought. Are you an emergent property of complex particle interactions in a base reality, or are you the product of an unimaginably sophisticated piece of code? The most unsettling part is, you may never know for sure.